Welcome back everyone to another video, and in this one we'll be taking a look at the amount of overhead we have while natively compiling for an architecture and using a cross compilation. Now this video started out as a benchmark between the Raspberry Pi and the CPU in my laptop, which happens to be a Pentium U3805, a dual core CPU clocked at around 1.9 gigahertz. So I really wanted to have at least some rough reference as to how my laptop stands against the Raspberry Pi 3, and I started off doing the normal kernel benchmark test that I usually do, that I've done with the Banana Pi and the Raspberry Pi 3, which has had a pretty good standing in terms of benchmark and uh, you know how close the CPU are in terms of performance. But the thing is, my Raspberry Pi took around 65 minutes to complete the compilation for its kernel, and my laptop, or I'm just going to call it the Pentium CPU, took around half an hour to do so. Of course, I was compiling the Raspberry Pi's kernel just to have both of them at the same level, but for a fact I know that my laptop is actually around 4 to 5 times better at raw CPU performance than the Raspberry Pi. But this test concluded that my laptop was only twice as powerful as the Raspberry Pi, and that is not the case. I mean, my laptop is capable enough to decode H.264 and H.265 at 1080p, software decode them without any issues, so without any hardware decoding setup and stuff like that. So it's a pretty powerful CPU when compared to the Raspberry Pi's ARM processor. But the matter of the fact is that the results weren't that great. And what I found out, that I was actually using cross compilation. I mean, I knew that I was using cross compilation, but it didn't struck me as to it would be affecting performance so much. And actually it did affect the performance very much. And so I went ahead and downloaded the actual vanilla Linux kernel directly from kernel.org and did some test, and I have a performance metric to tell you guys how well those things actually perform. So before I go into actually, the performance metrics themselves, I want to talk a bit about cross compilation and how it actually works. So think of cross compilation as video decoding. So you have an MP4 file, maybe it's an H.264 file at 1080p, and you have two options to decode that. So either you are going to use hardware decoding, or you are going to use the software decoding. Let's take an example of hardware decoding. Now in hardware decoding, what we are doing is we already have a hardware with a specific set of instructions to decode that particular codec, in this case X264, and that is actually going to do a much faster and a much better job, taking very little CPU overhead, as the CPU doesn't really have to do a lot of work. It just has to feed the data to the hardware decoder. Now in this case, this is similar to a native compilation process where you're not cross compiling. So for example, I'm compiling for the x86 platform on an x86 machine. So now those instructions that the binary code will represent are already with me. I mean, the whole system is already running on those instructions. That is nothing new to the system, so it's much faster to compile for a native hardware architecture. So now let's take the second example of software decoding. Now in software decoding, our CPU doesn't know how to decode an X264 file. Now to make it do that, we add a software decoder layer, and it has a bunch of instructions that helps the CPU in understand, or I'll say translates, the H.264 file to a set of data that can be processed and understood by our x86 processor, or let's say any processor for that matter. But since there is an additional software layer, our CPU is doing much harder work. It's utilizing more power, and it's generally at a much higher usage percentage, if you want to say. So it's doing a lot of work. Similarly, in cross compilation, there is a layer. So now I'm strictly speaking in the case of GCC compilation and cross compilation for ARM on an x86 platform. So if you're compiling for ARM on an x86 platform, the binary instructions for that ARM processor will not be the same as the x86 instructions at all, even if they are the same instructions. So what we have a set of libraries that help us do that. Now take those libraries to be that software layer in our video decoding example. Now they do add up a bunch of CPU overhead, thereby increasing our total time it takes to compile. So here's what I did, and this is not a apples to apples comparison in any manner. This is more of a real world test, and the values can vary, but the results I've got are actually pretty convincing. So I took the mainline vanilla kernel 4.9.5 straight up from kernel.org, compiled it once for an ARM processor, and I got around 20 minutes, which is almost the same I was getting for the Raspberry Pi's kernel when I cross compiled it. So the cross compilation took 19 minutes. So let's see what the native compilation took. And the native compilation took only 11 minutes. Now, as I said, I was expecting around 4 to 5 times the performance of the Raspberry Pi on my laptop, and this actually confirms that. Now again, this is not an apples to apples comparison, but I try to keep things as on the same level as possible, and I use the default configs for both the kernels. Of course, the ARM kernel has to compile a few more bits because the ARM environment is a bit more spread out, with every processor having its own boot code and its own GPU driver and stuff like that. So, but even then, from 20 minutes to 11 minutes is a big gap, and it proves the point that cross compilation actually takes a bit more of an overhead. So it would be interesting if I had a ARM CPU with virtually the same performance as that of my laptop, but that I don't have that right now, so I cannot confirm a few other things. But it proves the point, and it kind of makes sense right now. So this was only an experiment. I'm not trying to say that don't cross compile or anything like that. Of course, cross compilation is much faster, as you know, ARM processor are really slow. As you see, the Raspberry Pi took an hour to do what my laptop CPU could do in half an hour with cross compilation enabled. Nothing against cross compilation, just an experiment. As I said, this video was going to be a Raspberry Pi versus my laptop, but it actually ended up being more of a educational stuff for me, and I hope you guys also learned a bit more. Now I would request some positive feedback in the comments down below if I've missed something, or there could have been other variables involved in this test. Please do let me know down in the comments below. And thank you so much for watching. Like the video if you liked it, dislike the video if you didn't like it, and I'll see you all in the next one.